Okay, this is Unit 5, Video 9, Part 2, Practice with Empirical Formula. Okay, so we know with empirical formula, we can use percent mass to determine how many of each element we might have in a compound. And remember, empirical formula is the lowest whole number ratio of atoms in a compound. So what we're going to do on the board is we're going to do a little practice with maybe if everything we're normally used to being in the problem isn't there. So we might have to use a little algebra to solve these problems. So let's look at the first one. It says determine the unknown element in X is going to be our unknown. We don't know what that element is. And Cl4 if chlorine is 83.5% of the compound's mass. So notice we will have one of these, and we have 4 chlorines. So that ratio is going to be 1 to 4. What I don't know is what is X. So remember, for empirical formula, if it's in percent, we're going to assume it's out of a 100-gram sample. So I do know that I have 83.5 grams of chlorine. And I know that whatever is left over, so 100 minus 83.5 is my unknown element. So I'm going to have 16.5 grams of X. So first step is let's go ahead and convert this to moles. So if we convert this to moles, grams of chlorine is going to go on the bottom. We're going to go to 1 mole. This is 35.45. Okay, if you type that into your calculator, you're going to get that the moles of chlorine is 2.36. Okay, well, if I've got 2.36 moles of chlorine, we need to find moles of X, but we have a ratio. We know for every 1 mole of my unknown, I've got 4 moles of chlorine. So we can set up a mole ratio since we're already in moles of chlorine. So let's go ahead and set up a ratio here. We've got 4 moles of chlorine to 1 mole of X. Okay, so if you punch that into your calculator, you're going to get that the unknown is 0.589. Okay, now you might be saying, okay, well, what do I do with that now? I still don't know the element. But remember, whenever we're converting anything back and forth from grams to moles, we have to have the atomic mass, which we get off of the periodic table. So I have the mass, and I have the moles. So we can set up a problem now to where we just don't know the atomic mass. So we can solve for that mass. So let's take 16.5 grams of X. Okay, and on the bottom is our atomic mass. Grams of X normally goes in the bottom. I'm going to give it Y because that's what we're solving for. We don't know what it is. Okay, and I'm going to go ahead and get rid of this X just so you're not confused by it. This is grams of our unknown. And we know this is always to 1 mole. Okay, well, we can set this equal to moles of our X. So we can set it equal to 0.589 moles. Okay, so if you multiply this out, you're going to get 16.5 grams equals 0.589y. So if you punch this into your calculator, you're going to get that y equals 28.02 grams. Okay, well, we still don't know what 28.02 grams is, but we do know that this is our atomic mass. So we get atomic mass from the periodic table. We know the ratio is 1 mole because it's set it up here. It's 1 to 4. So we can go to the periodic table and we can look at it, the atomic masses, and see which one is closest to 28.02. So if we look at the periodic table, the closest one to 28.02 is going to be silicon. It's 28.09. So that's going to tell us what our missing element is. Our missing element is silicon. So if the missing element is silicon, we would write this as SiCl4 as our answer. Okay, now let's move on to the next problem. Let's say, what if now we don't have just 2 elements in our compound? We've got 3 elements. It's going to make us a little more difficult, but we can still do it. So here, it's saying determine the compound for KBrOX if bromine is 47.8% of the compound's mass. Okay, so we know, let's start with what we're given. For given percent, we know it's out of a 100-gram sample. So this is how much bromine we have. We have 47.8 grams of bromine. Okay, now if we subtract that from 100, we're going to get 52.2 grams of not just potassium or oxygen. It's both of them together. So it's potassium and oxygen. Okay? Well, let's go ahead and convert this to moles because we know from empirical formula we need to always get this into moles. So Grams of bromine is going to go on the bottom. We're going to go to 1 mole of bromine. Okay, the mass of bromine is 79.90. Okay, so if we do this, we get that the moles of bromine is 0.598. Okay, let's look at our compound real fast. The ratio here, just like up here, once we had moles of chlorine, we had to find a ratio to find our unknown. Well, to find the moles of potassium, the relationship or the ratio is 1:1. So if I have 0.598 moles of bromine, I also must have 0.598 moles of, not chlorine, moles of potassium. Okay, so the only one I'm missing is oxygen. Well, if potassium and oxygen is this mass here, I can convert this to mass. Let's subtract it from my total here. So next step is, let's convert this to mass of potassium. So moles of potassium is going to go on the bottom. We know this is 1 mole. Going to go to grams of potassium. Potassium is 39.10. Okay, so the mass of potassium is going to be 23.4 grams of potassium. Okay, so now I figured out how much potassium is in that total down there. So what we can do to figure out how much oxygen we have, let's take the 23.4 grams of potassium and let's subtract it. So if we go down here and we subtract 23.4 grams of potassium, okay, we get 28.8 grams of oxygen. Okay, so we know for empirical formula we need to get everything in moles. So let's look at what we have right now. We've got 0.59 moles of bromine. I've got 0.598 moles of potassium. Only thing I'm missing is moles of oxygen. But I now have the mass of oxygen. So we can solve for that. So let's convert this into moles of oxygen. Gram of oxygen goes in the bottom. You've got 16 grams is to 1 mole. We punch that into our calculator. We get 1.80 moles of oxygen. Okay, we know the last step in the empirical formula is to divide by the smallest number. These are the smallest. We know there's a 1:1 ratio because it was given to us. So we divide by 0.598. We get 1 here. We're going to do the same thing. We get 1 there for potassium. We need to divide by 0.598 for the oxygen. If we punch that into the calculator, you get 3. So what this is telling us is that for X, we've got 3 oxygens. We've got 1 potassium, 1 bromine, and 3 oxygen. So this is our final empirical formula.